All right, our objectives today for our 4-1 assignment will be to graph linear equations using slope and intercept, or just the intercepts, and then we'll also graph linear equations. Okay, example 1 says to determine if the given point is a solution to each equation or inequality. Now this is a review. We actually did this in our last unit, and I did it in preparation for this unit. To solve this, what you will do is you will take the ordered pair given and substitute it in for the values and see if it makes your statement true. So we're going to replace this y with a -5 and also replace it for the x and then solve that. And we get -5. If you take -1/3 times 3, you get -1. -1 plus 2 is 1. So -5 is greater than 1 is how that statement reads, and because it's not true, we would say no. This is not a solution to that inequality. That point 3, -5 is not a solution. So for B, we do the exact same thing. We go in and we replace the y with 7 and the x with -1, and then we solve it. So we have 7 on this side. 3 times -1 is -3, minus 4 is -7. And again, this is not true, so this is no. That means that this point here, -1, 7, does not lie on the line y equals 3x minus 4. Okay, onto our definition of slope. And this is a review. We have talked about slope a lot. Last unit we talked about it as a rate of change. Slope can either be positive, negative, you can have no slope, or it can be undefined. We talk a lot about slope being rise over run. And then we also have these two formulas, y1 minus y2 over x1 minus x2. We can reverse that order and go y2 minus y1 over x2 minus x1. Both of those will give you the same answer, but we have talked about this in class, that if you start with this y1 on the numerator, then you have to start with the x1 in the denominator. So again, over here, you want to make sure that those values come from that same ordered pair. To find the slope between each pair of points, we'll use that formula. And in this case, I'm going to take -2 minus -5 over 4 minus 3 and simplify that. When you have two negatives together on the top, you have -2 minus a -5. That becomes plus. So -2 plus 5 is 3 over 4 minus 3, which is 1. And you can either leave that as 3 over 1, or you can write it as 3 when you simplify it. So on B, we do the same thing. 9, I started with the second ordered pair this time. 9 minus 5 over 2 minus 0. So you get 4 over 2. We can reduce this, and you can either reduce it to 2 over 1 or simply 2. Okay, slope-intercept, y equals mx plus b. There's some things you need to know from this. First of all, that m represents your slope, and the b value represents your y-intercept, and that's where it crosses the y-axis. Standard form is another form that we're going to look at today. You did use it last year, ax plus by equals c. And I'm showing this equation to you because it is a lot easier to graph using the intercepts when the equation is in standard form. There's a lot less work that has to be done. So an inequality graph looks like this. It has what we call a boundary line. The boundary line can be dashed or it can be solid, and that all depends on the inequality. It will be dashed if it's greater than or less than, and if it's greater than, less than, or equal to, then it becomes solid. And we also shade a region. In this case, it would be all of these values over here. They're considered above the line. And those would all be solutions to our inequality. So to graph an inequality, the first thing you want to do is solve for y so that it puts you in the y equals mx plus b form. From there, you're going to identify your slope and your intercept and use those two pieces to graph. Then you're going to graph the boundary line, and you will make it solid, and I just talked about that on the previous page. If you have the greater than or equal to, less than or equal to symbols, and it has to have that equal to, it'll be dashed if it's missing that equal below it. The last thing you'll do is you will shade above or below the boundary line. If y is less than or equal to, you will shade below. If y is greater than or equal to, you will shade above. Sometimes that's really hard to determine what's below or above, and if it is hard to determine, a way to check is to pick a point and put it into your equation and see if your equation gives you a true answer or a true statement or not. And I'll show you how to do that in just a second. So here's our graph. It's linear, it's in slope-intercept, so identify the slope. It's 2 over 1. The intercept is -3, so when we go to graph, you're going to go down 3 first, and then up 2 over 1, up 2 over 1, and then you'll draw your line. This has no shading because it's just an equation. As we continue on example 3, you're going to notice that second one is an inequality. And we're still going to identify the slope and the intercept. Because there's no number next to the x, we're going to say that it is 1. We'll write it as a fraction, 1 over 1. And our y-intercept is 2. So we'll start on our graph at up 2. Then we'll go up 1 over 1, up 1 over 1. Or we could go down 1, back 1. And that gives us this line. But before I draw it, because it's an inequality, I want to determine if it is a solid or a dashed line. It is a dashed because there is no equal. And because it's an inequality, we have to determine where we shade. The problem reads y is greater than x plus 2. So because it's greater than, we want to shade above. But if you're not sure, pick a point. I like to pick 0, 0 if it's not on the line, and plug that in. If I put 0 in for y and 0 in for x, I get an inequality that will read 0 is greater than 2. This is not true, so that tells me the point that I chose, 0, 0, is not part of the shaded region. And that will justify that I did shade the right direction on my graph. So on C, it's not in slope-intercept, so we need to solve for y first. To solve for y, we're going to subtract this 3x over, and then I'll write below the graph what it looks like. So I get negative y is greater than or equal to negative 3x plus 2. We're going to divide each part by -1 and get the equation y is less than, remember when you divide or multiply by a negative, you have to flip that inequality. So y is less than or equal to 3x minus 2. Our slope is 3 over 1. Our y-intercept is -2. So I go to my graph. I start at -2. And then I go up 1, 2, 3 over 1, go up 3, or I could go down 3 and back 1, and then I get a line. From that line I have to determine if it's solid or dashed. It is solid because we have an equals there. And then we have to shade. Do I shade in region 1 or region 2? The graph says that we will shade below it. And so that would be region 2. If you're not sure, pick a point. I like to pick 0, 0. And I always go back to the original equation to put that in. If I put 0, 0 into the equation, I get 3 times 0 is 0, minus 0 is 0. And that says 0 is greater than or equal to 2. Now we know that that's not true, so that point that I chose should not be part of the shaded region. And it is not, so I have shaded the correct area of my graph. So we move on to our next type of problem, and it wants you to graph using the intercepts. Remember, intercepts mean x-intercept is when the y value is 0. So we're going to take our equation and replace the y value with 0 and then solve it. Right here this it becomes 0, so I'm just going to cross it out. And we're left with 3x equals 6. Divide by 3 to solve this, and x equals 2. You're going to find that you're going to be able to do this faster than what I'm showing you right now. The y-intercept then is when the x value is 0, so we put 0 in to our equation for x and solve it. This piece will become 0, so I'm going to cross it out, and we get 2y equals 6, divide by 2, and y is 3. So I'll put that into my ordered pair, and then I'll graph both of those. I have over 2 up 0, and over 0 up 3. We get a line like this, and we do not do shading because it's an equation, not an inequality. So for example 4, I chose an inequality. We're going to do the same thing by finding the x-intercept. The x-intercept is when y is 0, and I'm going to show you the shortcut because I know I'm putting 0 in for y. The 2 will become 2 times 0 is 0, so I'm just left with 4x is less than or equal to 4. And we'll solve that by dividing by 4. So x is less than or equal to 1. That inequality really doesn't matter. I'm just using it. I could replace it with an equal sign if you prefer and then solve it, but then go back to the inequality when you graph. The y-intercept is when x is 0, so I put 0 in for x, and that 4 times 0 becomes 0, so I'm going to leave it off and write negative 2y is less than or equal to 4, divide by negative 2, and y is greater than or equal to negative 2. Okay, so I can go graph those 2 points, over 1 up 0, over 0 down negative 2. I can draw a line. It is solid because it is an inequality, and then I have to decide region 1 or region 2 to shade. So I'm going to choose a point here, 0, 0. I'm going to put it into my inequality. 4 times 0 minus 2 times 0 is less than or equal to 4. When you multiply 4 times 0, you get 0, minus 2 times 0 is 0, 0 minus 0 is 0, is less than or equal to 4, and that's true. So that means wherever that point is that I chose is part of the solution, so that means I will shade in region 1. And that should take you through your assignment. Good luck. Most of this is a review, and it should be pretty easy for you.